Hello, this is the video to go through the conclusion and evaluation for the paper helicopter investigation. Hope you had a really good fun time doing it and got some interesting results. If you just did it and had fun, brilliant. If you didn't manage to record any results, that's okay, because I've got my set of results which you can then look at. What we try and do is we try and answer these 5 questions when we write a conclusion and an evaluation. The first 2 questions are about a conclusion, the last 3 are an evaluation, and they're both really important parts of doing science investigations. So as you can see here, these are my results. So I had each wing length from 2 centimeters up to 22 centimeters, and if you watch the other video, I kind of did these ones first with the longest length and then cut away 2 centimeters each time, so my wing length got shorter and shorter and shorter until I got here. And so you can see, I'll kind of do it this way. So you can see with the shortest length, I had the shortest times really. And then as the wing length got longer, the times got bigger. And this is probably the best bit to look at, the averages. What I did with the averages is I just added this, this and this together, divided by 3, and that gets you your average. It's called the mean of each column. You'll look at that in year 6. The average at 2 was 0.9, and so on. You can see it's getting bigger and bigger and bigger. Around 12 to 14 centimeters was when it was its longest to fall. So both of these averages were to 2.2 seconds, and then it kind of goes down again into a kind of shorter time. And then this was the best time out of all of them was in 14 centimeters, which was 2.5 seconds. But both of these two are pretty much good wing lengths. Now the reason I've got this highlighted is because I'll discuss that later, but it's something I would like to maybe investigate a little bit further. So when you do yours, now if you want to just write your own conclusion and evaluation now, based on your own results or these results, don't scroll down, just look at those. So look at those questions and these results. If you want a bit more help, I've also written my own conclusion and evaluation. So you can kind of use this if you did the same investigation as me, but you might have got slightly different results. Maybe your test was a little bit different. And maybe you want to discuss the results that you got, which is brilliant. I'd love to kind of see what you did. But in my investigation, I found that up to a point, the longer the wing length is, the longer it takes to fall to the ground. That's my conclusion. My results table shows that the average drop time increases up until about 12 to 14 centimeters in length, then begins to decrease again, with the longest drop time happening in the 14 centimeter length. That's that one there. My prediction was correct. That's what I thought was going to happen. And the reason this happens is because the wings have a larger surface area. Where is it? A larger surface area, so that means it's got more kind of space in it as they get longer. So the force of air resistance has more chance to oppose the force of gravity. So remember when we did our the PowerPoints earlier in the week, you've got the force of gravity going down and the force of air resistance going up when things fall. But when the wing gets too long, what I think is that the mass of the object is too much for the air resistance. Remember, mass is just the word we probably should use instead of weight. The mass of the object. So that's too much, so air resistance doesn't really have an effect. It's too heavy and just falls more quickly because of gravity. So that's my conclusion, that bit there. And then we move on to our evaluation. So in most experiments, there's probably a way to improve it. So even though I tried to do mine as best I could here, I could have probably improved it by filming each drop so that I could see the exact moment of it being let go and touching the floor, and then calculated that by taking away those 2 times, and then I could take out the human error of measuring, because when I'm saying go, someone's pressing start on their phone to record it and then stopping it when they see it hit the floor, and there's a difference between those reactions. So that could have been a bit better. I could have also repeated each drop more than 3 times. I could have done it 5 times, 10 times. If I had all day, I could do 100 times for each one. and then my average would be really, really good. And any weird results wouldn't matter. Looking at the results though, so now I'm answering question 4. Are there any results I'd like to test further? I'd probably want to do this one again, just because I've got a 2.5 and a 2.3. I would maybe expect all of them to be above 2, but maybe even. And then that might actually mean that if this was 2.0 or 2.1, it would bring this average up a bit. So that average might be 2.3 or more. And so that would be the optimal wing length, 14, rather than just 12 or 14. So that's probably the only one I really want to test, because all the others kind of seem about kind of where they should be if you take into account the other two. This one's quite different from the other two, so actually maybe this one would be another one I'd maybe look at again, because that's really different from the others, but not that much different. So that's probably the only one I'd look at again. And then my final question, I really like this question because once you've done one investigation, hopefully that makes you think about doing another one that's kind of similar. So I'd be really interested to see what you want to write for this. This is kind of what you on your own think. So it's what investigation that's like this one we've just done would you want to do next? So for me, the investigation I would like to do next, based on the one we've just done, is maybe change the wing width instead of the wing length. And then in that way, I'd maybe see if that has an effect. And if I did that test, my prediction would probably be quite similar to this one. I'd probably say that if it's a wider wing length, the wider wing length would slow the drop, just like the longer wing does, because of surface area and air resistance. So there you have it. That's the end of the investigation. I hope you really enjoyed it. It's bank holiday on Friday, so I hope you all are safe and maybe get a chance to do something nice. I'll see you again on Monday.